Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire and today I've got Sangdon Lee, who has just completed the course ROS2 Basics using Python, and he'll be giving us a presentation on that. So let me now hand over the platform to him so he can begin his presentation. Alright, whenever you're ready.
Okay.
Alright, you can just give a brief intro of the stuff that we'll be doing, Sangdon.
Oh yeah, sure. So this is the basic Python course. Pretty much there's two different sections that we had to do. No class with class. Class is pretty much you have all you can use self, so it's pretty much more convenient. You don't have to write functions over and over again. You can just also like use variables from the init statements. So it's more convenient, and I believe that we'll test the naive obstacle function that we have created in the robot control class file. And in this course, we had to set some basic like initiating speed or like duration for the turns or how fast it's going. So for instance, I just made a helper function for my CMD where I pretty much set the linear and angular velocity. And this is the duration part for the timed. There's a different functions for like moving the robot to the front in a specific time and rotate the robot in a specific angle. So with using these helper functions for the time move front, I use the absolute, just making sure when I type in, no matter, let's say I get confused with front and back, or if I'm rotating robot left to right, I make sure that my functions change the values to absolute values. So for instance, left turn is always going to be positive, and right is negative. It could be a little bit confusing because people tend to think turning right is always positive and left could be negative because of the x coordinations of the math, but it's different for this. So that's why I set it up. And when it's angle divided by absolute value of radian, because angle equals the radian, the angular speed, times time. So when we put the angle for this, we have it in the run, and when we go up, you can see that we that's like the duration. So that by doing that, it gives the function to how much time it's gonna turn. So that way we just need, and I can put in any values for these functions. So it's pretty much a lot of parameters. I try to make it straightforward by speed, duration, radian, angle. So, but you have to be careful that you type in order. If you like type angle in radian, it's gonna put that value as radian value, and then you might not get the result that you want. So by using these simple formulas like scan ranges index, get front range, get left range, there are different functions that you're required to code. And by using the functions that you have created, you make the naive obstacle avoider function. It's pretty much that in the instructions in the course, they give you the threshold. I believe I set it up as 0.3, and then you wanna get all the scan ranges of your laser to scan the front, left, and right. In this instruction, they don't require you to scan the back range because it's always gonna be moving in front. And in order to get the index of the scan value, you have to use this formula. So what this is doing is that it has the minimum, I believe the minimum angle is negative 180 and the max is 180, and therefore it covers the 360 degrees. So by doing this, you are calculating how many increment steps to get this value. So let's say pi over 4 is 45 degrees, and I guess minus mean angle, let's say, is 180. It'll calculate how many times it had to increment in order to get this value, and it will give you the index value for this. And just make sure that you round it because it might be decimal values and you change it to int from the full.
Okay. Okay, let's see this
And
working on the robot itself, and then we can get back to it later. We can get back to the code
okay,
later. Yeah.
sounds good. Yep. I guess it's too close to the wall already.
Yeah, you can move it back to the starting point, and then let's start again and see.
Yeah. Let's see. It's, for some reason, it's not, the joystick's not working. Oh, there is it. There we go.
Yep, okay.
Wait, what? I'm sorry about that.
It looks like your threshold values are not set properly, but you said you set them to 0.3. I wonder why it did not stop. Yeah. And are you actually stopping the robot when it realizes that the threshold value is gone below 0.3?
So turn and go right. So for every run, I have the self-stop robot function in there, and I those. I only use those functions. So like turning angle right, like turning angle left, move front. Oh, since for this function, I think for the SCMD, I don't have the self-stop robot, so I might want to add the self-stop robot just to make sure it stops after each movement. Yeah. Yes. Wait, was I doing the no class instead of the class?
I think you're doing the no class version, but my assumption is they're all supposed to work in the same way, isn't it?
Oh, because
yeah, unless you change the implementation of each function when you switched it to the class version, I thought. They must all work in the same manner. It's just the type of programming style that you're using that changed. So which one is running right now?
It's a class
version. Okay.
Mm-hmm.
And no velocities have been set so far.
Mm-hmm.
Yeah, did you run this before and it worked the way you expected?
Yeah. I don't know why it's breaking a lot.
Okay, so you're getting... Okay, let's wait for it before we start going there, because I also want to know, is it because of the frequency at which the ROS node is publishing command velocities or something else? Seems to be doing okay now.
Yeah. Well, I don't know when I did it, we didn't have this weird like stopping thing. Maybe I am not giving it enough time to change the when I publish comments. It's like,
yeah, I don't think this is an issue with your code. It's I think it's something to do with what's happening out there in the pipeline that sends commands to the robot.
no, but my code is still, it's not working right. I guess it's stuck in the values between the.
Okay.
I guess the learning angle is great enough. The robot.
Can you? Okay, I think I didn't hear you clearly. You said?
So the angle by its turning is not enough, so I might want to increase the angle to like 40, like a 45 degrees, and for my like turning sharp, turn when I want to turn sharp, I might want to increase to like 50 degrees just to make sure it turns more than this, because I feel like 30 degrees isn't enough.
Oh, so you're using 30 degrees right now?
Yeah.
Okay,
yeah.
let's do something. So open your IDE and open the robot interface.py and let's see.
In here?
Yeah. No, the robot interface script. So if you go, let's see. Can you scroll up a little?
Yeah. This is not the robot interface that you're talking about?
Yeah, no, that's the one that I want to see. So go up a little bit again. Okay, just hang on. So I want to see. I know you're not supposed to touch this script, but I also want to know at what frequency is it publishing command velocities. So maybe we can get it to be a lot smoother. Go a little bit up again. Okay, one more time. So, timer. Yes, on the timer. Okay, can you using time period?
Like a control timer?
Yeah, that's the one I want to see. So the time period is 0.1. Okay, reduce it to 0.01. No, 0.06. Okay, so let's see. So you have to run it again. I want to see something quickly.
Let me change the.
No, leave the angle like that. Because this will tell us if your code was working correctly earlier or not.
Okay. So you want me to like reset the robot into the.
And then start it again. Yeah.
What the fuck? So every time it clicks, it changes.
Yeah,
Oh, it's better now.
it's better now. Okay, that's good. So let's see.
Yeah, I think 30 degrees is too small. It's turning a lot. I might
And
have to increase the value.
yeah, it's top, but so there is a trade-off here. So sometimes you want that because it can avoid obstacles that are like small. So for example, those
Sure.
the cons. So if you make it too wide, sometimes it misses them completely. Um, so it's a trade-off. But right now it looks to be okay. So that's fine. So this is the class version that is running at the moment, right?
So I didn't really on the thing
Mm-hmm.
on the instruction it said it will work with the classed PY, not the no classed.
Mm-hmm. Mm-hmm.
That's why I only did the naive obstacle for the
For the class version.
classed.
Yeah, it's good. It's good.
Yeah.
I just wanted to make sure it's the one that we were looking at. All right, so I think this is good. You can keep explaining your code, and then we'll get in some
Okay.
questions after. Yeah.
Okay. So do you want me to watch the robot while I explain, or?
I think we want to look at the code now. We want to look at the code more. So
Okay, I see.
I guess it'll be easier for you as well to explain the stuff as you see
Oh,
the
yeah,
code.
yeah. So pretty much what we are doing there is this code right here. We at the very end we have this thing called try, and we make it while true, so this code function can run consistently.
Mm-hmm.
And then for this code, like I explained before, you need a threshold value. It's the safety distance for your robot. So let's say when the front range is lesser than 0.3, then it's gonna do a certain action in the below or the conditional statements that I set up. This is a scan ranges. So the robot has scan ranges of I don't know the whole ranges, but it gets the ranges from different sensors, and that's the information is provided through the ROS2. Minimum angle is you can't type the minimum angle to see what's the minimum angle for your robot. It could be different. It could be -90, negative 180. So make sure you check the minimum angle in the terminal by the command code provided from the instructions. And the angle increment is how much angle gets incremented. You can find this information in your terminal as well if you're curious about it, but you need these two things. I use these two things to find the index for different ranges. And for the angles, I use the pi. I just use the math function. And this is what I talked about. In order to get the index, you have to use the function. So I use the 45 degrees for the front left and -45. So I'm pretty much covering the front 90 degrees by using this. And the left index, I use the 90, and right index, I use the -90. And then you want to use this for the ODM. In the terminal, they want you to track the current ODM for the robot and have the positions for the previous X and previous Y. I'll explain about where we'll use this information. And so we have scaling. I don't know why we have that one more time, but we use this, and then I use the front left index and left index. And since sometimes ranges could be out of boundaries, or there could be errors and noises in your scan ranges. So you want to make sure that your front left index and left index is in the range, like valid ranges. So just make sure it's not below 0 or it's not above the length of the scan ranges. That's why I have it set up as I use this class function at the top. And you want to use this index to get the scan range of the front left scan range. So you put the scan ranges and you get the index. You use those index that you have set up at the top, which is front left index and left index plus 1.
Mm-hmm.
And you want to make sure that smaller angle is in the lower value and the bigger angle is on the right value. So the index is set up, in sorted. So you don't want to make sure you don't want to have the higher angle in the left and lower angle on the right.
Mm-hmm.
I think that's why you have to be careful. And if you want to include the index at 90 degrees, you want to do +1 because that's like basic Python. It will exclude the top. If you just do that, index is going to exclude it. And then you pretty much repeat the process for different indexes. And after you get all the ranges that you need for this function, you have to have the minimum scan range because you want to get the minimum value in that scan range in the list to compare it to the threshold we set up at the top. So we use this function, which is get minimum range index. So it's we use a enumeration function, enumerate. I don't know what you call it, like enumerate. I guess it's like a built-in function.
Yeah.
We'll give you the index value of the list. So you see there's a parameter that I set up. It's pretty much that we put the range values, the list of range values that we got from below, and we put it here, and it will enumerate through the range. Oh no.
Yeah, no, it's quite weird. Weird seeing that it works. Okay, so.
And then just make sure the scan range isn't int or like negative. So I use the isFinit function, and then scan range is if, and then it's like below the mean value.
Okay, so since we're running out of time a little bit, so let's get into a little bit of questions. So let's say you wanted, so right now you implemented a generic like obstacle avoidance algorithm, right? If you were going to modify that algorithm to allow you to follow your wall in a, for example, counterclockwise direction, that means always having the wall on the right side of the robot, right? If you're going counterclockwise, yes. How would you do it? So from
Can you repeat the question again?
So if you had to make sure that in addition to avoiding obstacles, your robot is able to follow the wall while keeping it like on its right side, how would you do it? Which part of your code would you modify to do that?
So if you wanna modify the code to make sure the robot always follows the wall,
in a counterclockwise direction,
yeah. So like, so you're saying that when we're at this here, we'll turn to the wall and go to the wall and turn left, so it follows the wall, or what? Like when you say counterclockwise, what you mean by?
Yeah, so if your robot approaches the wall and then it turns left, right? The act of turning left itself puts the wall on the right. So yeah, that situation, how would you do it? That is the one that will ensure counterclockwise direction wall following.
Wall following. So let's say you always wanna turn counterclockwise. Then you might wanna set the robot by like use the keyboard to make sure that first you wanna have the robot in like a specific location, and maybe I'll add like the algorithm to find the wall. Let's say since if always gonna be on the right side, if you wanna rotate the robot counterclockwise, I would turn clockwise to find the wall because it's always gonna be on my right side robot, and I would use the front index to compare it to the minimum index, like use the value that I use, the function that I used, the minimum range index. It provides the minimum index and minimum range, and I'll use the minimum index and compare it with the front range index, and I'll would have like there's gonna be it's not gonna be perfect, it's not gonna be equal. So I'll say I'll subtract the front index and the minimum index, and if it's like, I guess, less than 3 or 5, then it's close enough. That means it's fake. There's a obstacle detected in front of it. And I'll move the robot front, and then I'll turn counterclockwise, and I'll make the robot move. But when it moves, you want to set the conditional statement saying that while the robot gets closing to the wall, let's say you want to give the threshold to 0.5 to be safe. If it's in the range, you want to make the robot to stop and then turn counterclockwise and follow. And during that follow, you might want to set when the robot is too close, you want to turn counterclockwise by like 0.1, let's say. If the robot is closer than 0.3, then you turn counterclockwise. If it's too far away from the wall, then you turn clockwise to make the robot closer to the wall.
Yeah.
And if it's like in perfect balance, let's say robot is in the range of like 0.2 to 0.4, it's in the range, you just make the robot go straight. And you already have the conditional statement for when the robot detects the wall in the front, and you just make the robot stop and turn counterclockwise and repeat the process again for every walls.
I feel like you're leaving one very important part, and that is with respect to the index that references your wall. So right now you're talking about always considering the front range, right? So you're looking at the index that is right in front of the robot.
So if you want to be more like specific, maybe you can use the front left, front right, use the 90 degrees, and could pretty much use the same thing that I did to get the whole like range. And during that range, you use the minimum in there because it's gonna get all the ranges from left to front right, and you want to do the minimum range where it's closest to the wall, where it's detecting, and you can use that value with the minimum index in all the ranges and compare them together to make sure that wall is like robot is facing the wall, but it's detecting an obstacle.
Yeah, well, I do get that, but I slightly disagree on getting all the ranges, because if you're going to be following the wall in a counterclockwise direction, isn't it you just want to keep the wall that is on the right side in check, right?
Oh yeah, you need the right index as well when you follow. Yeah, I forgot about that.
Yeah,
So you
exactly.
want to get the right index as well. So when you follow,
Yeah, that's the part I was
you
looking
need
for. Because if you're gonna keep
you
that,
need two things.
yes, if you're gonna keep that distance constant throughout the following behavior, then you need to monitor that closely. So in addition to monitoring your front ranges data, you also need to monitor the data that's coming from the right range. So yeah, I'm glad you got there just a little bit with some nudging.
I forgot about that. Thank you. Yeah. You definitely wanna, if you wanna make sure that your whole balances in that 0.2 to 0.4 range, right? You want to consistently track the right index or right range value to see that it doesn't go over that range.
Yes. All right. Wonderful. Thank you so much, Sangdon. It's been a good presentation. So just hang on. We'll just finish up here. Alright everyone, this was Sangdon Lee's presentation, and a warm congratulations to him. I would like to encourage all those of you who would like to try out this course or any of the courses we offer education on to do so, and then you can come and also showcase your work and carry out a presentation. And until next time, keep pushing your ROS learning. Bye bye.